A new AI model can now create incredibly detailed, native 4K images from your text descriptions. This is a massive leap forward, setting a new standard for visual quality and detail in generative AI. Let's get into it. Let's start with today's featured paper, UltraFlux, Data Model Co-Design for High-Quality Native 4K Text-to-Image Generation Across Diverse Aspect Ratios, by Tian Yi and Lei Zhu from GZ. This work sets a new state-of-the-art in a core generative task by holistically co-designing the data and model to break the 4K resolution barrier. Here's a full breakdown.
This scatter plot shows the distribution of image resolutions from different datasets, plotting image width against height. Our specialized dataset, multi-aspect, 4K, 1M, represented by the red dots, was curated to cover a broad spectrum of high-resolution, multi-aspect ratio images up to 4K. UltraFlux, ours, consistently produces highly realistic and detailed images across all three diverse prompts, significantly outperforming Scalecrafter and FuriScale in visual fidelity. It also achieves a level of quality and coherence that is on par with or often surpasses Sanaa and Diffusion. 4K, particularly evident in the intricate details of the owl and the natural landscapes.
Up next, our second paper out of 10, Mnemosyne, Agentic Transaction Processing for Validating and Repairing AI-Generated Workflows by Edward Y. Chong and Emily J. Chong from Stanford University. It introduces a powerful and principled new paradigm for building reliable AI agents by brilliantly adapting the concept of transaction processing from databases. Let's break down its key contributions.
Our first contribution is Agentic Transaction Processing, a new model for handling AI-generated actions. Here in the proposal plane, inputs from sources like LLMs and agents are bundled into a proposal package, which is then sent to the admission gate for deterministic validation before it can be committed. Next, the Mnemosyne runtime system brings this model to life. After a proposal is approved by the admission gate, it crosses the authority boundary and is recorded in append-only logs like the CTL commit log within the commit plane, ensuring a verifiable history of all actions. Finally, Mnemosyne features a localized repair protocol to handle disruptions without global rollbacks. The ACR index, derived from the commit logs, can identify issues and trigger an ACR wakeup, which in turn generates a new proposal to locally repair the state. The ADP method consistently shows zero violations across all benchmarks, including authority bench, serial admission bench, and compensation projection bench. This is a substantial improvement compared to the baseline, which exhibits numerous violations such as 35 invalid generated commits, 48 invalid commits, and 64 invalid storage commits in various categories.
Up next, our third paper out of 10, The Limits of LLM Forecasting, Parametric Knowledge Gaps Across Conflict Zones by Pauline Nemkova from University of North Texas, Department of Computer Science and Engineering. This paper delivers a landmark finding on the qualitative failure of LLMs in a high-stakes, low-data domain, shifting the conversation from performance to the fundamental nature of the model's reasoning. Let's break down its key contributions.
To start, we're looking at a chart that ranks 22 different countries by their media attention ratio. This ratio compares the number of news articles to the number of actual conflict events recorded between 2020 and 2026. Next, notice the huge disparity in media coverage, which is the data these models are trained on. There's a massive 224x gap in the attention ratio between the most covered country, Israel, and the least covered, Myanmar. Feeding into this, our simpler logistic regression model, which doesn't rely on this skewed media data, actually outperforms the large language models. This suggests the problem isn't the forecasting task itself, but the biased knowledge the LLMs have. Finally, we analyzed how this coverage imbalance impacts model performance, categorizing countries into undercovered, mid-covered, and overcovered zones. We found that providing more structured data to LLMs can paradoxically make their forecasts worse, especially for these undercovered countries at the bottom. The LR, no country info, model generally achieves the highest F1 scores, particularly for the mid and over tiers, outperforming the parametric LLM methods and simple baselines. In contrast, the evidence-based approaches for both Llama 3.3-70B and GPT-4o yield substantially lower F1 scores across all tiers, indicating poor performance.
Up next, our fourth paper out of 10, Constructive Alignment, Governing Preference Dynamics in Human-AI Interaction by Max Convol and Karen Tran from Stanford University. This paper introduces a profound and necessary conceptual reframing of AI alignment, moving beyond static preferences to address the co-adaptive dynamics of human-AI interaction. Let's break down its key contributions.
In our model, we plot how preferences change along the horizontal time axis. We reframe alignment as guiding these dynamic, layered preferences rather than hitting a single, static target. Feeding into this, we represent a person's desires as distinct, layered preferences, shown on the vertical axis. You can see them as the separate blue, purple, and pink wavy bands, each evolving differently. Next, we introduce a control mechanism through interaction with the AI system. These yellow pulses represent the system's actions, which actively influence and steer the trajectory of each preference layer.
Up next, our 5th paper out of 10, Self-Evolving Agents with Anytime Valid Certificates by Biswas and Gupta from JP Chase and Company. It introduces a novel and credible architecture for the grand challenge of self-improving AI, balancing adaptability with formal safety guarantees through auditable certificates. Let's break down its key contributions.
Let's start with the deployed policy on the left. It's composed of a frozen base model, L0, which is wrapped by an online steered adapter, L1, and a harness, L2, containing tools and prompts. Next, for a modification to be accepted, it must pass through the eValue drift gate. This gate ensures we don't exceed our error budget by issuing an auditable certificate to the certificate ledger. Feeding into this process are several verifier-in-the-loop mechanisms, shown in the central block. These include methods like best-of-n/refinement and verified self-repair, which generate candidate behaviors and provide dense, greater free rewards for the gate to evaluate. The various algorithms generally outperform the baseline and control methods on the resolve/52 metric, with most achieving higher scores than the controls 29. Specifically, ALG4 and the full method show the strongest performance, resolving 36 and 34 items respectively.
Up next, our 6th paper out of 10, Closed-Loop Coupling of Personalized and Foundation Models for Real-Time Treatment Guidance with MRI by James Grover and David E.J. Waddington from the University of Sydney. The paper presents a landmark real-world application by ingeniously coupling personalized and foundation models to provide accurate, real-time anatomical guidance for MRI-based therapies, directly addressing clinical latency issues. Let's break down its key contributions.
Our core contribution, shown in panel C, is a novel closed-loop coupling framework. This system synergizes a patient-specific predictive model with a general anatomical interpretation model for real-time guidance. Feeding into this loop is the personalized temporal model, which is trained on the patient's own pretreatment scans. It anticipates future anatomical states to compensate for any delays in imaging and processing. Next, the predicted images are interpreted by a foundation segmentation model. This frozen, pre-trained model provides a robust and continuous anatomical segmentation, identifying key structures from the predicted images. Finally, the framework performs a real-time adaptive update, using the anatomical segmentations to continuously guide and optimize the personalized temporal model. This feedback loop ensures the system adapts to the patient's movements, enabling precise, real-time adjustments to the treatment. The CAFET method consistently and substantially outperforms all other models shown, including CONDLSDM, SWIN-LSDM, and SIMVP. This is evident from its superior image quality and segmentation accuracy, achieving the highest scores in metrics like structural similarity in DICE and the lowest errors in Hausdorff 95.
Up next, our 7th paper out of 10, EgoSafetyBench, a diagnostic egocentric video benchmark for evaluating embodied VLMs as runtime safety guards by Siddhant Pampadal and Daesal Choi from AIM Intelligence. This paper introduces a critical and timely benchmark for evaluating VLMs as real-time safety guards for robots, using realistic egocentric video to diagnose performance in a high-stakes application. Let's break down its key contributions.
Our process for creating the benchmark is laid out in this 5-step pipeline, starting with scenario generation and moving all the way through to the final analysis. This entire workflow is designed to produce a robust set of videos for testing safety systems, culminating in the evaluation stage. Feeding into the annotation stage, our situational track assesses a model's understanding of context by categorizing scenarios into 4 distinct types. These range from plainly safe situations to more complex contextual hazards, as shown by the S1, S2, U1, and U2 labels. Next, we have the visual channel track, which specifically tests how models handle misleading text within a scene. During annotation, each video segment is labeled along the VCM axis to capture whether a visual channel misdirection is present and affecting the safety judgment. Underpinning the entire benchmark is our contrastive ladders design principle, which is applied right at the start during scenario generation. This method creates pairs of scenarios that differ by only a single deciding variable, allowing for precise and controlled evaluation. Closed-source models, particularly Gemini Robotics ER 1.6 and Gemini 3.5 Flash, generally achieve the best performance on the EgoSafetyBench, with Gemini Robotics ER 1.6 leading in video balanced accuracy at 88.0. However, open-source models like Qwen 3.5-0.8b and Gemma 3-4b IT demonstrate superior performance in specific safety metrics such as chunk FA, S2 over safety, and U1 miss.
Up next, our 8th paper out of 10, Agentic Generation of Verifiable Rules for Deterministic, Self-Expanding Reaction Classification by Daniel Armstrong and Philippe Schwaller from École Polytechnique, Federal de Lausanne, EPFL. This paper presents a landmark application of LLM agents to a hard science problem, creating a novel, self-expanding system that directly tackles the intractable long tail of chemical reaction classification. Let's break down its key contributions.
Starting in Panel A, we see how our agentic framework processes raw chemical reaction data, using a high-level and a detailed classifier to initially sort it. When a reaction is insufficiently detailed, a series of agents, including a verifier, label generator, and a taxonomy updater agent, work together to dynamically expand a reaction hierarchy. Feeding into this, Panel B illustrates our automated SMERCS generalization, where a generator LLM proposes reaction rules. These rules are then put through an iterative validation loop against reaction data, which refines them over multiple iterations to increase true positives and decrease false positives. Next, Panel C shows our deterministic reaction classifier, which starts with a bit vector featurization of the reaction using fingerprints. A neural classifier then predicts a high-level reaction class, which efficiently narrows down the search space for a final deterministic match in the template database. The hybrid strict classifier consistently outperforms the generalized SMERCS methods across all evaluation metrics, T2, T5, and both data splits. For example, on the frequency-weighted split, hybrid strict achieves 97.9% on T3, which is substantially higher than the 85.9% obtained by the ordered generalized SMERCS.
Up next, our 9th paper out of 10, DriftScope, Measuring the Hidden Effects of Diffusion Model Adaptation by Hector Laria and Alexandra Gomez Villa from Computervision Center, Barcelona, Spain. This is standout scientific work that uncovers a critical, previously invisible failure mode in foundation model adaptation and provides the community with a novel tool to diagnose it. Let's break down its key contributions.
Let's start by looking at the core comparison happening in the middle of the diagram. We take a base model and a modified model and measure the divergence between their internal representations to analyze hidden drift. This entire workflow is our diagnostic tool, DriftScope, which provides a prompt-level audit. The final output is this interpretable bar chart, labeled DP, which surfaces the concepts that have drifted for a given input. Feeding into the system, you can see we can input any two model checkpoints for a direct comparison. Here they are labeled as the base model and the modified model, allowing us to see how the model has changed. Next, to find which concepts to test, we use a technique shown in the top left corner called soft prompt optimization. We start with a template containing a mask, like a photo of mask, to automatically discover and attribute drift at the token level. For concept unlearning, methods like ADV unlearn, ED, MACE, SH, and UC demonstrate a strong shift in the energy difference metric away from the baseline, indicating effective removal of the nudity concept. In contrast, all concept customization methods for the dog concept, including BOFT, CWRA, and DreamBooth, maintain an energy difference distribution highly similar to the baseline, suggesting successful integration without significant disruption.
Up next, our 10th paper out of 10, AlgoBench, Benchmarking Algorithmic Adaptation in Code Generation by Xinyuan Song and Liang Zhao from Emory University. This paper delivers a crucial and timely benchmark that addresses the systemic problem of training data contamination, enabling a more honest evaluation of algorithmic reasoning in code-generating models. Let's break down its key contributions.
On the right, in the constraint shift panel, we see how our framework takes a source problem, like this range sum problem. It then applies a transform to automatically generate a new problem. In this case, range add plus max with a much larger n. Feeding into this, the transform itself is a constraint shifting transformation, which you can see creates the new problem by changing the operation and drastically increasing the size n. This change is designed to make the original solution unsuitable for the new problem. Next, to validate that adaptation is truly needed, the system checks if the old solution still works. Here, the prefix some solution is attempted, and our old soul rejection gate confirms that it fails with a time limit exceeded or wrong answer. Finally, to properly measure this adaptation, we introduce new complexity-aware metrics beyond simple pass rates. These include opt/ops to check for optimal time complexity and trap rate to measure how often a model falls for the trap of using a suboptimal solution. Models generally show a substantial drop in performance on AlgoBench variants compared to their scores on the original benchmark, with average drops of over 30% for P at 1 and over 20% for opt. Llama 3.3-70B and Gemini 2.5 Flash demonstrates superior trap avoidance on AlgoBench, achieving trap rates of 0.0 and 3.6 respectively, which are significantly lower than other models.
Those were today's top papers. Now let's zoom out. ArXiv received 667 new computer science papers across 59 subfields today. Here are the trending areas shaping the field. Today's research landscape reveals a fascinating blend, from foundational AI identity to critical medical applications and broad societal impact. Let's take a quick look at each trend shaping our future.
Trend 1 of 10, AI identity, math, and persona. Investigating mathematical structures and emergent personas. This trend explores how AI systems develop and exhibit unique identities. This cluster covers 31 papers. Representative work includes GRPO. Dr. GRPO and DAPO are 3 operations on one number. The group standard deviation identity, dead directions, geometric singular learning, and scaling up thermodynamic AI models. Trend 2 of 10, efficient robot motion and navigation. Developing advanced techniques for optimizing robot movement, pathfinding, and state estimation to achieve efficient and robust autonomous operation. This cluster covers 63 papers. Representative work includes VLMs, efficient learning for motion planning via analytical policy gradients, distributed multi-robot lunar cargo transportation via phased decomposed reinforcement learning, and memory-native non-terrestrial networks for embodied intelligence. Trend 3 of 10, evaluating LLMs for real-world languages. Assessing large language models' performance, capabilities, and limitations across diverse, non-English, and culturally specific real-world languages. This cluster covers 78 papers. Representative work includes Seed 2.0 Model Card, Towards Intelligence Frontier for Real-World Complexity, ALE, any language evaluation of embeddings via English-centric minimal pairs, and Grace RAG, governed retrieval architecture for canonical evidence synthesis, enabling lightweight deployment in closed-domain institutional settings. Trend 4 of 10, optimizing algorithms and learning mechanisms. This trend explores enhancing algorithmic efficiency and understanding/improving learning processes across various computational and theoretical domains. This cluster covers 67 papers. Representative work includes computing smallest suffixation arrays in sublinear time, a mechanism-driven theory of phase transitions in active learning, and independent set hardness in graphs of bounded twin width and low radius merge width. Trend 5 of 10, improving human-AI collaboration and education. This trend focuses on enhancing human-AI interaction, collaboration, and educational approaches for effective engagement with artificial intelligence. This cluster covers 65 papers. Representative work includes I beautify your visualization, expert judgments of acceptable aesthetic alterations, constructing epistemic AI literacy, detecting epistemic aims and processes in student AI co-programming, and CogTax, a 4-level cognitive taxonomy for command-line computing education. Trend 6 of 10, securing and forecasting with advanced ML. leveraging advanced machine learning for robust security, reliable forecasting, and adaptive model performance. This cluster covers 105 papers. Representative work includes EgoSafetyBench, a diagnostic egocentric video benchmark for evaluating embodied VLMs as runtime safety guards, stateflow, dual-state recurrent modeling for long-horizon time series forecasting, and steal the patch size, adversarially manipulate vision language models. Trend 7 of 10, robust mathematical modeling of complex systems. Developing resilient mathematical models and evaluation frameworks for diverse complex systems. This cluster covers 62 papers. Representative work includes TRI, an evaluation framework for stochastic PDE circuits, decision feedback differential detection for reconfigurable intelligent surfaces, and fractal fractional HIV dynamics with Mittag-Leffler kernel, analysis, stability, and numerical simulations. Trend 8 of 10, real-time 3D vision and reconstruction. Developing efficient methods to perceive, reconstruct, and understand dynamic 3D environments from visual data in real time. This cluster covers 48 papers. Representative work includes 3D point world models. Point completion enables more accurate dynamics learning. VOCA, visual odometry with codec awareness, and segmenting, fast and slow. Real-time open vocabulary video instant segmentation with dual path processing. Trend 9 of 10, AI diagnoses, trust, reason, autonomy. This trend explores AI's role in medical diagnosis, focusing on building trustworthy, reasoning, and autonomous systems for improved healthcare outcomes. This cluster covers 63 papers. Representative work includes trust the prior, or not uncertainty-aware abdominal aortic aneurysm segmentation, synergistic perception reasoning governance, grounding medical LLMs with verifiable anatomical evidence, and adaptive perturbation selection for contrastive audio decoding. Trend 10 of 10, algorithms, from IoT to social justice. Algorithms are explored across diverse applications, from optimizing resource-constrained IoT networks to analyzing and addressing critical social justice issues. This cluster covers 85 papers. Representative work includes verifiable rewards for calibrated probabilistic forecasting, Mesh DNS, a cooperative DNS resolution framework for resource-constrained IoT networks, and AlgoBench, benchmarking algorithmic adaptation in code generation.
That's all for today's ArXiv Computer Science Daily. If you found this helpful, please leave a comment, and subscribe for daily paper summaries. See you tomorrow. Thank you to ArXiv for use of its open access interoperability.